Okay, for the calculus unit 5 review, y equals 2x plus 2. What is the minimum value of the product xy? So since we're trying to find the minimum value of xy, we're going to call that p. We need to take the derivative of p. So we're trying to optimize the product. So we're going to use that y is 2x plus 2. Substitute that inside y. Okay, we're going to distribute the x. Okay, and now we're going to take the derivative of the product. So the derivative with respect to x is going to be 4x plus 2. We're going to set that equal to 0. So x is negative 1/2. Okay. So what is the minimum value? Well, we have x times 2x plus 2. So the minimum value would be negative 1/2 times 2 times negative 1/2 plus 2. So negative 1/2 times negative 1 plus 2. So my minimum product would be negative 1/2. Okay, for number 2, it says a police cruiser approaching a right angle intersection from the north is chasing a speeding car that has turned the corner, is not moving straight east. Okay, so we have a police cruiser coming from the north, and then we have a car that has turned a corner and going east. Okay, when the cruiser is at point 4, so we're going to call the cruiser Y. So when the cruiser is at point 4, and the car is at point 9 to the east, the police determines with radar that the distance between them and the car is increasing. So dz dt is increasing at 17 miles per hour. If the cruiser is moving, so if the cruiser is moving at 47 miles per hour at the instant measurement, what is the speed of the car? So we're trying to find the x dt. Call that x. Okay, so I'm going to have to use the Pythagorean theorem. So x squared plus y squared is equal to z squared. So 2x dx dt plus 2y dy dt is going to equal to 2z dz dt. So then we're going to go ahead and substitute everything we know. Okay, so we have 2 times 0.9. We're trying to find dx dt plus 2 times 0.4 times 47. But notice that he's going down, so we're going to call that negative 47 equal to 2. We don't know what z is, but we can find it using the Pythagorean theorem. So z is the square root of 0.97. So we're going to put that there, and dz dt is 17. So if we solve for dz x dt, it's 39.492 miles per hour. So the cruiser is going, or the car is going 39.492 miles per hour. Number 3 says a water runs into a cylindrical tank at a rate of, and it should be cubic, 15 meters cubed per second. So the dv dt should be 15 cubic meters per second. The tank stands point down. Okay, so here's my tank, and it has a height of 29 with a radius of 20. How fast is the water level rising when its water is 16 meters deep? Okay, so here's the water r, so we do have a dr dt, and the height of the water, so we have dh dt. So we want to find the rate of change of the water when the water is 13 meters deep. So we're going to have to use the volume equation, which is 1/3 pi r squared times h. Okay, so I don't know anything about r or dr, so I'm going to use similar triangles. This is 29 and 20 to solve for h. I'm not going to substitute 13 because the water can change at any moment in time. So this is where I want to freeze it, so I'm not going to substitute that until the very end. So we're going to have r is to 20 as h is to 29. So r is to 20 as h is to 29. So r is 20 over 29h. Okay, so substituting that into my volume equation, I get 1/3 pi 400 over 841 h cubed. So now I am able to take the derivative. So it's derivative dv dt, 1/3 pi times 400 over 81 are coefficient, so I can just bring it down, times 3h squared times dh dt. So my 3's cancel. My volume is 15. Now I can substitute everything I know. Times 400 or 841. I want to find out when h is 13 squared. And then I just solve for dh dt. So dh dt is equal to 0.0594 meters per second.